Hey guys, we're going to talk about logarithmic functions this time, converting logs to exponents and vice versa, as well as talking about domain and range, simplifying some equations, and graphing log functions. So first thing to remember is that logs are exponents. That's really what it means. They can be rewritten as an exponent. That's what a log means, is that it's asking for the exponent. Log equals exponent. They are exponents. They equal exponents. So what that means is that the number that's on the right side of a log, so equals, that is the exponent. Logs equal exponents. So that is the exponent on that side. Just like in our first example here, b to the x, x is the exponent, x is the piece that goes by itself with the logarithm. Log equals exponent. So by putting that together, 4 squared is 16, so that's why log base 4 of 16 is 2, because 4 squared is 16. We could rewrite that as 4 squared equals 16. That's all it means when it's talking about converting, writing logs as exponents, exponents as logs. You can also use your calculator. Your calculator has buttons for base 10 and base E built right into it. So right up here, you do have a log button, which is for base 10, and then natural log, which is base E. So when we do anything with logs, we can type them in that way. There's also, it's a little bit hidden, but you can go to Option. And then it is... I always forget. I think it's in Calc, so F4. And then log AB. Now, depending on your calculator, there's different ways to type it in. This one is nice. It has the boxes. You just have to type into the boxes. So we can fill in a 2. And then in the other box, if we filled in an 8, this answer should be 3, because 2 to the 3rd power equals 8. And that's exactly what it is. If you were using a different calculator, with the one that most of you have, you actually would have to type it in as log, and it would open up a parenthesis, or it would say log AB, and it would open up parenthesis. You put the base first, just like I typed in the 2 first, and then you would type in the other argument, the 8, and your calculator will tell you 3 if you type it in that way. It's the exact same steps, but you just have to type in 2, 8. Again, the comma button is right above the delete button. So you type that in for the comma. So we can work these out. Most of these you don't require a calculator for. You can answer these just by thinking through it. Because remember, it's the exponent. Log equals exponent. So we're trying to answer the exponent. What exponent would make a 3 become 27? That's 3. 3 to the 3rd is 27. What exponent would make a 4 become 1 over 256? That's a little bit trickier. To get the 1 over, it's going to be a negative exponent. That's how you create a fraction using an exponent. And then to get 256, 256 would be 4 to the 4th power. So that's what it would be, negative 4. 4 to the negative 4th would be 1 over 256. Log 100, when they don't write any number here, no base, it's implied that it's a 10. So 10 to what power equals 100? That'd be 10 squared, so 2 is the answer. Natural log is base E. So E to what exponent equals E? That's a 1. And then this last one here is a little bit tricky, and it leads us to our next topic. 2 What power creates a negative number? There's no exponent that will give you a negative solution. So there's no solution to this. It's undefined. Because it's a negative. Which is exactly what we're saying here. You cannot take the logarithm of a negative number. It's not a domain, is what the other way that we're going to talk about that on the next slide. So, solving, or not solving this out, but just working this out. This is log base 5 of x equals e. So, to solve it, we need to convert it first into an exponent. So remember, 5 is the base. The base of the log is the base of the exponent also, so 5 is the base. The answer is the exponent. So we convert that into an exponential. 5 to the e equals x. And then you could just box that, or if you wanted a decimal, you could do 5 to the power of e. And then we just want a 1 there because it's e to the first. So 5 to the power of e is some strange decimal, 79 point something. It's totally okay if you just leave it this way. You don't need a decimal approximation. Same idea here. This natural log is base e, so this is saying e to the negative e equals x. And again, you can just box that. We don't need the decimal for that. So, like we just said, you cannot take the log of a negative number. That's the domain. The log part right here, the parentheses, cannot be negative. So 2 minus x squared cannot be negative, which means it has to be greater than 0. It also cannot equal 0, so we'll always just do greater than 0. And then we have to solve that out, and to do that we will think back to when we solved these quadratic equations. We can solve by factoring, but since it's quadratic inequality, we're going to think of the graph. So this is a negative x squared. It's going to cross the x-axis twice. We'll get those two solutions by factoring, hopefully. And then we're looking for where is it greater than 0, which would be the top piece of the graph, which only has the one section. So to get those two numbers, we solve it out. I'm going to change all the signs. So it's a positive x squared. So we can factor. Multiply by negative 2, add to be 1 would be positive 2 and a negative 1. So our solutions are x equals negative 2, x equals positive 1. That's what these two numbers are. Negative 2 is further to the left. Positive 1 is further to the right. So our interval right here is from negative 2 to positive 1. Negative 2 to positive 1. It's this section in between because we're looking above the graph, and this is the piece that is above the graph. And then it's also not equal to, so it's a parenthesis. So that's our domain. That's all there is. The next one's quite a bit easier. We just take, again, we take the parentheses part. 5 minus 2x. Same thing, it cannot be negative. It has to be greater than 0, not even equal to, just greater than. So then we solve it out. Divide by negative 2. Since we're dividing by a negative, we have to flip the inequality. And then as an interval, if you want to start by graphing that, that's totally okay. It'd be 5 halves. And then it's less than, so we're going to the left. And it's not equal to, so it is a parenthesis there. So that would be negative infinity to 5 halves. with a parenthesis, and infinity always gets parenthesis. So that's it for domain. You always take parentheses greater than 0. We're going to simplify, which this requires us to do a little bit of thinking, a little bit of work here. Again, natural log is base e. Now, anytime, and maybe you remember this from Algebra 2, but anytime you have the base and the argument of the log, the number that would be in parentheses right there, so the e, whenever those match, they cancel out. So the e's cancel out the natural log, really, and then we're just left with -2. A different way to kind of work through this, it's a little bit more of an explanation here. So if we say x, and now we rewrite it as an exponential, we would take the base to the part that it equals. So this becomes the x, becomes the exponent, e to the x equals, and you take, finally you take the parentheses here, e to the -2. Just rewriting it the way we did in the very beginning. Then you can see that x has to equal -2, and that is the answer. The other piece, and just that shortcut that I was kind of referring to, is natural log and e will always cancel out. Natural log and e will always cancel out. So, especially often I write natural log this way. So it's natural log of e, and I kind of exaggerated it on purpose, but if you look at the way I wrote ln, if you just erase that bottom part, now it kind of looks like the word 1. That's exactly what it is. Natural log of e is always equal to 1. So whenever that happens, we're just going to be left with the exponent here, because the rest of it's 1 and it's kind of gone. So natural log of e, again, that's 1, but now this one is a little bit different. There's a property in here that in number 1 that I skipped over. We're going to save that for the next lesson, but it has to do with this exponent here, so we'll save that for our next lesson though. But if you think of natural log of e as just being 1, this becomes 1, now that's parentheses to the -2. The difference is the parentheses there. 1 to the -2 is still 1. 1 to no matter what the exponent is, the answer is just 1. Alright, for the last part we're going to look at graphing. It's going to come back to parent functions. So here's a parent function for log base 2. A couple things that will always happen is the domain is always going to be 0 to infinity. Unless it's, of course, shifted left or right, then that will change. The range will always be -infinity to positive infinity. There will not be a y-intercept because there's an asymptote there. It does not touch the y-axis because of the vertical asymptote. And the x-intercept would be at 1, 0 for the parent function. It's going to be at 1, 0. So this has some shifting that goes on, but then everything else is the same. We just have to remember we start with the vertical asymptote and then draw it, and this first point is always 1 space away. So -2 means shifted to the right 2. +1 means up 1, so we're going to do our shift first. Right 2, up 1, that's our new origin. The base this time is 3. It's not log base 2 like the last one. It's base 3, but that doesn't change. Our vertical asymptote's the same. That's too thick. Vertical asymptote's the same. The point, our first point is always going to be 1 space to the right of our origin, and then for the rest of it, it's just the powers of 3. So then whatever, since this was base 2, it would be the powers of 2 going to the right. When it's base 3, it's just powers of 3 to the right. So 3, 1, 2. And then the next number will be 9, which is going to be just off of our graph. So that's all we're going to get. Do your shift, and then the parent function points.
Who's shooting? I'm on the other team.
So this negative in front of this one is going to reflect it. Remember, when there's a negative in front of everything, it reflects it down. So instead of graphing up and to the right, it's going to be graphing down to the right. So there's no shifting going on, so it starts, our origin is the origin. Then we go, our parent function points, we know it's going to hit one space. And then this time it's just going down. So we're going to keep our parent function points of log base 2, which is now the powers of 2, but we're going down and to the right. So now we go 2 to the right and down, and then 4, because that's the next power of 2, and then 8, because that's the next power of 2. 2, 4, 8 is the powers of 2. Vertical asymptote's still there. Trace it out. You don't have to draw the vertical asymptote. Especially if it's the y-axis, it's basically there for you. The negative inside, remember, that's just going to flip it left-right. So instead of graphing the normal way, it's going to graph flipped to the left. Origin doesn't change. Instead of going to the right, we're now going to the left. Again, the base is 2. So our first is 1 away. And then the powers of 2 would be 2, 4, and 8. That's it. Natural log, just remember, is base E. And we talked about when we graphed E, those numbers are 2.7 and 7.4. Same process though, so our first step is the origin, which does not shift. Then 1 space away, because there's no reflections. And then it's 2.7 away. And then 7.4 for our next step. That's it. All right. Your homework is the worksheet. You can find it in the Files tab up top. Post any questions you've got. Good luck. Let me know.